All right, so we're live and recording, so we can hear Sada doing One Little Slip by Bare Naked Ladies from the Chicken Little soundtrack. By all means, Miss Vega, take it away.
Take it away. You have to start it off.
Was a recipe for disaster. 4-course meal of no siree. Come on, Sada.
One little slip.
All right. Okay, guys, today we are working with rational equations. I've got 4 steps written. Let's stop talking, please. Jada, Sarah, Wyatt, Tylee. Thank you. Solving rational equations. Factor all denominators and numerators, if possible. Set all denominators equal to 0 and locate excluded values. Multiply the lowest by the lowest common denominator on both sides. Solve the resulting polynomial as normal. Any solutions that equal the excluded values are not solutions. They are called extraneous solutions. So we're going to, Aaron, I'm going to steal your paper. I'm just going to write down our first example. A plus a squared minus 5 over a squared minus 1 is equal to a squared plus a plus 2 divided by a plus 1. So let's go through that step by step. Anthony, let's factor, please. Can we factor anything up there? The answer is yes, by the way. On the right side, the numerator on the right side? Let's factor the numerator on the right side. What does the numerator on the right side factor to, Anthony? We can't. We can't take an a out of it because the 2 does not have an a. We're not just factoring one thing out. The right-hand side factors. Maybe. Okay. Does it, actually? A plus 1 times a plus 1. So you're saying 1 times 1 is 2? A plus 1, so you're saying 1 plus 2 is 1. A minus 2, a plus 1. So you're saying negative 2 times positive 1 makes positive 2. A minus 1, a plus 2. So you're saying negative 1 times positive 2 makes positive 2.
But if I switch it, you said negative 2 times.
Positive 1 does not make positive 2. But it doesn't matter. Either they both have to be negative or they both have to be positive, but they have to add the 1 in the center. The right-hand side is not factorable. I said, Anthony, is something up there factorable? The answer is yes. I didn't say the upper right side is factorable. And just in case I'm wrong on that, you guys can go back to the video and listen and see whether or not I said it. Are you mocking me, Miss Petroff? Am I funny to you? Am I a joke? Am I here for your amusement? Okay.
So it's going to be a lot of steps.
No. So the bottom right's not going to factor either. It's just a plus 1, obviously. Yes. Bottom left, what's it factor into, Watkins? A plus 1, a minus 1. Difference of 2 squares. Okay. So first thing we need to determine are excluded values. Excluded values, which says in step 2, set each of the denominators equal to 0 to find excluded values. So this one doesn't even have a denominator, so I don't care about that one. So this step is excluded values. And I'm going to set a plus 1 times a minus 1 equal to 0. So that's my first denominator. So if I do that, what do I do after this step? You guys should know. I'm going to move this. What can I do? What should I do? Watkins? No, that's just going to get me back to that. Set each one equal to 0, correct. So a equals -1 and a equals 1. Those are two excluded values. Then I would set, technically speaking, this is a good reason to review the video, I would also set this last denominator equal to 0, but I already did that right here. No, because this is an excluded value, so we don't have a multiplicity. Good question. We don't have a multiplicity on an excluded value. All right, so these are my excluded values right here. So no matter what, when I finally solve this out, if when I solve this out, it says a, I work it all the whole thing out, and I suddenly get, hey, a is 1. Can't be 1. Or I work the whole thing out, and I get a is -1. Nope, can't be -1. Any other answer I get, I'm good with. But I cannot, at the end of it all, get a equals 1 or a equals -1. Those are excluded values. Huh? It would be a more advanced algebra because of the fact that we're doing with these rational equations.
Could we just put a equals plus or minus 1 since you started with the square root?
Sure. All right. Step 3. Multiply by the LCD of both sides. This is going to take up, if you guys can't tell, I gave you a big old page of room, so make sure you're ready for it. What is the lowest common denominator of both sides, or the least common denominator? Close. A plus 1 is a denominator. This one doesn't have a denominator, so I'm fine. If I multiply this fraction here by a plus 1, will the fraction be completely canceled out? No. What else do I need then? A minus 1. There's the LCD. Be very ready here for the next thing. I can pause for upwards of 15. There's Victoria laughing at me again.
But I have a question. You don't have an a minus 1 on the right-hand side.
I know, but I need to cancel all fractions, left and right side.
So does that mean that the a minus 1
And didn't what's number 3 say on the last 3 words on step 3?
on both sides?
On both sides.
So does that mean that you would multiply the a minus 1 into the top?
I will. I will. Destiny, you ready? Okay. Destiny. So I'm going to multiply to that first one. Okay? And so I will have a times a plus 1 times a minus 1. Are you okay with that? Cool. Amaya, when I distribute to the next part, what's going to happen?
So the a plus 1 and the a minus 1 will cancel out.
And what will be left?
A squared minus 5.
There we go. Lucas, what's going to happen on the right-hand side now? Math will occur. What's going to cancel, Lucas? Okay, the a plus 1 will cancel, and what won't cancel? The a minus 1. So I'm still going to have an a minus 1, and it's going to be multiplying by that entire right side of a squared plus a plus 2. So right here, guys, this a plus 1 times a minus 1 is just going to become a squared minus 1 again. Because that's the conjugates. Conjugates, if you don't recall, binomials where the only thing that's different between them is the center sign. Or at least one sign. You look like you discovered something horrifying on my laptop, hon. Oh, okay. Yeah. Okay. All right, Manuel, what's going to happen over here on the right-hand side? Do what? Yeah, distribute. A times A squared is? A times A? Uh-huh. Let Manuel do it, please. And 2A. Then the negative 1. Yep. And there we go. I'm going to distribute this one because I want to feel smart. Oh, I'm going to combine like terms. So, what goes on the right-hand side, Aiden? And what would I get? 0. They cancel. Ta-ta, ta-ta. Yep. Those are going to combine. I'm going to get A minus 2. Negative 1 times A squared? Oh. I don't know. Good question. No squared on that. There was no squared on that. My apologies. A times negative 1. Good catch, Albert. Good catch. You weren't confused. I was wrong. The difference. Anthony, you need redemption. Okay, never mind. I've got to hold on for a minute. Well, I'm going to guess I've got to hold on for 8 seconds. What, this A cubed? What's up?
Are you trying to get everything onto one side?
I will. I got to get this equal to 0. So, Anthony, what'd I do? You want to move everything to this side? Okay. Jada says no. She wants to move it to the left. Okay. What do you want to move to the left then, Anthony? Add 2. Look at you controlling them like that. Go ahead. Subtract A. Yeah. All right, Anthony, A cubed minus A cubed? Negative A minus A. Negative 2A. I'm going to move that A squared to the front. And negative 5 plus 2. Now this is factorable. Negative A minus A is negative 2A. It was 2A minus 1A made positive A, but then I'm moving it to the left, so I subtract A from both sides. Okay, Indigo says this factors into A minus 3 times A plus 1. Because negative 3 times 1 makes negative 3, and negative 3 plus 1 makes negative 2. Hold on a minute here. Excluded value does not count. A is 3 is the solution. I'm going to do a 15-second Wyatt digestion as Wyatt turns around and stops talking to Sada. Quit controlling Wyatt.
Can it not be a negative?
Huh?
Can it not be a negative?
No. Can it not be a negative? The answer is no. It could be a negative solution. However, it can't be negative 1 because that's an excluded value. Hey, calm down.
I'm just saying. Yeah, thank you.
You're welcome.
Sorry, man. We posted up.
What was that, Victoria? What would you say?
I said we're posted up in this math class.
We're posted up in this math class. What does that mean?
Like we're chilling in here.
We are chilling in here.
Why do you say it like that? We are chilling.
We're doing this joke, aren't we? We're pulling this joke now.
All right, guys. Shh. You guys are socializing too much. You're writing down what's supposed to be written down, but we are not thinking about the math.
You're very right.
So, okay, this is how you solve a rational function. Now, we're going to do something called decomposing into partial fractions. Decomposing into partial fractions. I'm going to do a pencils down, eyes up type moment to see what it looks like with just numbers, okay? So pencils down, eyes up. If I know two fractions add to some other fraction, give me a fraction that doesn't reduce, please. 1/4. Okay? If I have 1/4, 7/13, ooh, I like that. But 1/4. I like, actually, you know what though? Give me a, I'm going to actually say no to both of those. I want my, it can't reduce. I'm going to limit you a little further. Also give me a composite number of 2 primes. Two is not a composite number of 2 primes. So so 6 is a composite of 2 primes. It's 2 times 3. Composites are non-primes. So I want it to be a composite of only 2 primes. Now 2 and 2 are 2, but I want them to be the same prime. That's the big thing. I'm gonna 11 and 1. I don't want 1 to be. So 6 is fine. 15 would be fine, right? So 14 15ths. Let's go with 14 15ths. Okay. Or anything. Okay. So 14 15ths. Guys, shh, here's the concept between decomposition of fractions. I have 14 15ths, and I'm asking what could have added to 14 15ths if they did not have a common denominator. So it would be something over 5 plus something over 3, right? Because if I got a common denominator, the common denominator would be 15, correct? And this would be some number over 5 and some number over 3. Okay? So it's fairly simple. It's fairly simple. All I do is I multiply both sides by the LCD. Okay? And I get 14 is equal to 3a plus 5b. Okay? Huh? Because I wanted to cancel. So when I distribute here, all that's left is the 3 and the 5. So now I say if a is 0, if a was 0, I'd have 14 is equal to 5b. If b is 0, then I have 14 is equal to 3a. So b is going to be 14 fifths. A is going to be 14 thirds. Mm-hmm. Right, so now we've got 14. A is 14 thirds. So now this one's not going to do much. 14 thirds over 5 plus 14 fifths over 3. I think I did something a little error. I think I made an error in the concept. Because this is going to be 14 15ths plus 14 15ths, which is not 14 15ths. Let me look at my steps. Oh, that's why, because I'm doing it without a variable. I'm doing it without a variable. I made an error. The concept is somewhat here, and I apologize for that. So when I said let a equal 0, I'm not supposed to let a equal 0. There's my error. I don't let a equal 0 and b equal 0. I let x or y or whatever, like in the coming problem, if in the upcoming problem you say I have y as my variable, I would let y be some number that cancels a. I'm not making a 0. I'd make y be a number that cancels a. I let y be a number that cancels b. My apologies there. Which I'm glad that I did a pencils down, eyes up, even though some people are still distracted back there. So the concept, the majority of the concept was there, and I apologize for leading you astray for a minute. We're going to decompose 8y plus 7 over y squared plus y minus 2. Giving it y squared, what was it? Okay. So really quick, guys, let's factor that bottom. Lucas, can you factor that bottom for me? Y plus 2, y minus 1. Fantastic. So my denominator is factored, so this is going to be equal to a over y plus 2 plus b over y minus 1. So I take the two factors of that denominator and I make them individually denominators on the other side with some unknown numerator. We're going to do 2 more steps, and then this lesson will continue into tomorrow. So just please follow through for the 2 more steps. I'm going to multiply both sides by the LCD, which is y plus 2 times y minus 1. Okay, I'm going to pause for a moment. Make sure you guys understand what I did. You all right, Victoria?
Yes.
Yes, Aiden.
Is there a reason to use brackets?
Because I already have parentheses. So normally when I'm working math, if I have parentheses and I'm going something outside the parentheses, I'll jump to brackets. And then if I'm going outside of that, I'll probably jump to parentheses again. Just, it helps me keep track of where they all are, what applies to what.
Why is a y plus 2 not y minus 1? Or is it just because it's in that order?
So what happened here, Aaron, is that when I did this times that one, the y plus 2 canceled, and all that would be left is the y minus 1. And when I do this one, the y minus 1 will cancel, and all that will be left is the y plus 2. So now that concept that I messed up a little bit on the numerical one, this one's going to be spot on. I let y equal something that cancels the a. What would y have to be that would destroy the a? A 1. If y is 1, I get 1 minus 1, which is 0. And then that'll cancel it out. So I let y equal 1. Then I get 8 times 1 plus 7 equals a times 1 minus 1 plus b times 1 plus 2. I can see me talking. No, I know they're talking. I don't stop them. It's just that way when they come up and they're like, I don't understand. Yeah, well, you're not paying attention in class. What do you want? 15 plus a times 0 is 0. Oh, not plus. 15 equals a times 0 is 0, and we have 3b. So b is 5. Then we're going to do the same thing to find a in a second.
Y equals 1 to cancel out the a.
And now I'm going to do y equals what? y equals -2. But we're going to stop for now before we try that out. Yeah, we'll pick that up tomorrow because there's still even more to this lesson. It's a big one. You're fine, hon. Now people on the video who watch are going to be like, what student's he calling hun?